the topic we're dealing with today is test management, and I hope you can see my screen, because there are some things I'm going to tell you, and you come across this a lot. Actually, you're going to come across a lot of the stuff we'll be talking about today on daily basis as a tester. So we just give these guys another couple of minutes, and then we would start. Also, I gave you guys a task to do last week. Two people have responded to that and sent their task to me. So I would announce the prize for those two people at the end of the class. Okay, so those people have shown commitment to learning this, and they will get a prize from me. We just wait for another minute, and then we would start, because we have so much to do today, and I don't want to waste time, and I'm trying to fit everything into an hour. So okay, I think we can start. The class is being recorded, and everybody else will join us. Okay, so let's just make it go for it, because I don't want to waste time, and I've got so much to do today. So this is the 5th class in the series of classes on the foundation syllabus in software testing. Today we're talking about test management. Test management means a lot of different things to a lot of different people. I don't want us to get carried away by the definition of test management. The whole testing as a whole, as a concept, has to be managed. And this includes us testers, managers, lead, analysts, all sorts of testing. Okay. So today we're going to talk about our testing and what it means to be in testing, and how to do test management. Okay, so in every organization there are few ways that people do testing, and in these 3 ways that people do testing, some people engage their developers to do testing for them. So what that means is the testers, they don't have testers. All they have is developers who are doing coding, who are doing all sorts of development for them. But instead of engaging testers, professional testers, they would ask the sorry, the sun is going in my eyes. Right, they will ask the developers to actually do the testing. Now, if you remember in previous classes, I did mention something about degree of freedom. Now, degree of freedom means that if you are testing, you have no participation whatsoever in the development of what you're testing. You are not positively or negatively disposed to the application. You have no pre-knowledge of the application. You have no residual knowledge of the application that may interfere in your test effort. Like I said to you, I think last week as well, there's no right or wrong answer. When you're doing testing, when you're testing something for your client, whatever you find as your result, whatever you come across, whatever you come across as your result is the actual result. Okay, that is the actual result, right? You can take that to your client, and your client can decide if that's what they expect or not. Okay, now some people use developers to test. Some people have testing of one person who is not involved in the development. Some other organizations use a team Some other organizations use several teams of testers. Now, there are similarities and differences in how these people would work. Like, for example, an independent tester is on his own. He has to do the planning, the thinking, source out everything that has to happen. This usually happens in agile methodology a lot. Most of the time when they define the sprint and the participant of the sprint, they just put the tester there because they need to put the tester there, not necessarily because of anything else. It's just because, oh, we're going to test it, so we're just going to put the tester there, you know. Now, that has it has its own positive and negative. For sure, it does save on cost. Because if you have just one tester, sure, you can save on money. You can save on not spending a lot of money on the person and, and just paying for that person to do the job, as against employing a team of testers and all of that. The output should be the same because you are trying to get everyone to produce an output that will improve the quality of your product. I've listed here the benefit of independent testing. They can verify, challenge this. They can do everything themselves. They are the tester, they are the test manager, they are the test lead, they are the test team. Actually, it's a one-man testing. So they would be responsible to do everything. Now, on the contrary, if you have someone saying, oh, we have developers here, we're going to engage a team of testers. Okay. Welcome to those people just joining us. I'm sorry we started before you joined. We have so much to talk about today, and we need you to type in hello or hi to everyone so we know you can hear me and see me. And this, if you have any question, as usual, just type your questions out. Okay. Right. So some other people will go and take a team of testers and absolutely throw the degree of freedom wide open. You have these people that comes in, they have no idea what's been developed, they've not participated in the development. All we're going to give them is documentation to show that this is happening and you're going to test it. Okay. Now, that's the situation we'll find ourselves in a lot of times. A lot of you would have heard the term COTS before, COTS. Off-the-shelf applications, So in those kind of things, it's been built. You have not participated in the build. You don't know how to build it. Well, you're just going to test it based on documentation and all of that thing. And we've discussed about documentation previously. Now, when you have a team of testers that are not involved in the development, think how do you think the output will be compared to someone who was involved in the development? Now, if I'm part of a team that built something, I would have some level of bias on that thing that I've helped to build because it's my handwork. I'm not going to condemn or critique or rip apart or shred down my own handwork. I would have some level of empathy and sympathy. Now, as an independent tester, my level of sympathy and empathy is to the developers, not to the developed product. I would understand they are human, like myself. They have emotions, I don't want to blow their morale out of the water. I don't want to injure their ego and all of that. But everything that I can take out on them, I would absolutely take out on the product. So my empathy, sympathy, bias, belief, support, whatever, does not extend from the developer to the developed product. That's the difference. Because I am not part of it. I would go in there open-minded, open to all sorts of things, fully thinking about how does this work. I won't spend a second thinking about Austin built this. I don't want to hurt him by saying that is wrong. And then running around the office looking for someone to pass my feedback back because I don't want to hurt the ego of my team. That's not how testing works. Testing means that you respect the team, you respect everybody, you respect the developers, you empathize with them, you sympathize with them. This is their handwork that you're about to start reviewing and critiquing and testing, but that's where it stops. The moment the focus shifts from the product, from the developer to the product, all of that goes out of the window. Now you're dealing with the product. This is you. This is your own handwork. And this is where you come in. Okay? And as testers, that is what we do. So the quality of output you would get from professional testers is going to be better, in my view. Like I was saying, I'm biased because I'm a professional tester. It's going to be better compared to if you have a part developer, part tester testing. There is a testing role that recently just came up about 5, 6, 7 years ago. It's called software development in test. Software developer in test, SDET or something like that. SDET or something like that they call themselves. Now, these are partly developers and partly testers. They can write codes, okay? At the same time, they can run tests. Now, the sort of test they will be running is usually unit test, which is still a developer's remit, so to say. But you still need a professional tester to come in there and plan your testing and all of that, as you will see later in this test. So that's the difference between having an independent testing, a sole or lone tester as a team, usually in agile methodology group, which usually is an afterthought because they've got all the developers there. They have the project manager there, waving a wand. This week, for the next 2 weeks, we're going to develop XYZ. And the developers are there yet. My unit integration testing is working. I'm going to deliver this XYZ. And then they turn around and go, oh, we need to test it. Oh, yeah, grab a tester there. They just find a tester, chuck it on the team just to make the numbers. And then they go, you're testing everything. I've been in that situation before for a software consultancy called BJSS. If you Google them, you'll find them. They're quite big now, but I worked with them when they were not that big. And on the agile team, I was the only tester. And I had to plan and run the test and write the codes. And at some point, I was similarly doing the same thing the developers are doing. And I wasn't paid as a developer. I was a tester. So that's the thing about testing in agile strength, because you don't have the numbers. So you have to do the all testing, planning, execution, reporting yourself, which is not a bad thing to do, but it limits and the quality is seriously affected. Let's just put it that way. Okay, so that's the difference between that. And so before I go to the next slide, talking about test manager, test lead, tester, test analyst, I need you to remember one fact. Okay, we are all testers. Now, because I've been doing it for so long, I would be doing things like planning, strategizing, defining method and approach that we would use. And that's because I've been doing it for a very, very long time. That doesn't make me more of a tester than you just starting out, okay? You just starting out will be doing more of writing scripts, defining scenarios, reviewing, doing regression tests and exploratory tests and all of those things. That doesn't make you less of a tester than I am, okay? Regardless of what role, we give or what office we occupy or what name we call ourselves, remember, we are all testers. The fact is we all do testing. Now, because there are so many activities in testing that we need to do, each of us will do different things. So don't look at it like, oh, why is he a test manager and I'm not? The sort of things a test manager would do are the sort of things a beginner would not be able to do. For example, you may not be able to estimate or guess how long it's going to take you to test a piece of a software. I probably would be able to do. You may not be able to write a test plan. I probably will be able to do. You may not be able to write a test strategy. I probably will be able to do. But that doesn't make me more of a tester than you. The only thing I have that you don't have is not knowledge of testing, is experience. Because I've been doing it for so long, I know these things. Okay. I need to make that fact clear to you before we continue. Okay. Now, so as a tester who does the planning, right? I'm going to run through most of this because this is what a test manager do. But there will be questions about this if you're proceeding to the certification exam. So you still need to know it. Okay. Now, a test plan basically is a piece of document that outlines test activities for testing or for each phase and for each level of testing. For example, if we're doing integration testing, for example, we will have an integration test plan. If we're doing UAT, we'll have a UAT test plan. If we're doing system testing, we'll have for every level of testing you do, we'll have a test plan for it. And the test plan is basically a document that aligns the activity you're going to do, that aligns the who's going to do what, or the definition of what you're going to do, how you're going to work, your criteria, the um, um, defect class definition, entry, exit criteria. I'll show you. I'll show you a sample briefly, so you can see it. So those things have to be planned before you actually start. Otherwise, you'll be doing things haphazardly. You'll be doing things that you haven't actually planned. Okay, so you need to remember that at the beginning, someone has to plan. Someone has to plan the testing you're doing, and that includes having a test plan for of every level of um, testing you're going to do. So you know for a fact that when you're doing integration testing, this is what the plan would look like. When you're doing system testing, this is what the plan would look like. Now, a tester would not write the test plan. That is the job of a test manager. Now, you may be thinking or asking yourself, what is my relationship with a test plan as a tester? Okay. Now, your relationship with a test plan as a tester is the fact that whatever is planned, whatever is planned by the test manager, you have to implement. See what I'm saying? Whatever is planned by your manager, you absolutely have to implement it. You'll be given stuff to do. You have to do stuff on it, on the plan, but basically you have to do it. I'll show you a sample plan in a minute, but I don't want to distract you with that because it's a document and the document will be made available to you at some point anyway. So that's what a plan is, okay? The availability of the plan, right? The availability of the plan ensures that you are doing what you need to be doing. Everyone is focused. You're looking at the goal of what you're doing, and everyone is on the same page. The manager has done the plan. You, as a tester, you're implementing the plan. If I need you to write test script for me, that will be stated in the plan. That for this phase of testing, we're going to script it out. So the testers, the analysts, I call them, because you are not just testing. You're doing analysis as well. You're looking at the requirement, you're trying to interpret the requirement, you're trying to do one or two things, a lot of different things actually. So those things does count, okay? That's what a test plan gives you. Now, in a test plan, you would have scope, objective, risk of testing. In a test plan, you would the approach will be defined. Which approach or methodology are we going to adopt? What sort of things are we going to do? Some people will go, oh, we're doing agile, okay? And some people will go, we're doing risk-based testing. My favorite is requirement-based testing. You can't be wrong with that. If the requirement says A, you just need to interpret it, get a few people to review it, get the interpretation right, and then go look for it, go test it, okay? You need to define what integrating system is involved, what systems you need to test together, what system is being tested. You need to define what to test, who's going to test it, how many people do you need, how long it's going to take you, how the activity will be carried out. For example, on the day of execution, what time of the day do you start testing? When do you stop? If you're recording issues as you go, how do you do it? Do you stop testing at the end of the day and then log all your defect, or do you log the defect as you find it? All of these things will be defined in the plan. Okay. Budgeting. I wouldn't put budgeting in my test plan, but some people might do. So those are the fundamental things. And then the test schedule, how you intend to schedule the test, how you intend to run the test and execute it. You have to define that in the plan. Okay. So that's what the test plan does. Now, there is another document called strategy. Now, the test strategy is an organizational level document. It sits above a test plan. So basically, for each organization, there should be one test strategy document. That is the manual, that is the Bible of that organization with regards to testing. It basically means this is how we do testing here. It has so much in it. I'll give you samples as well, just so you can look at it. I'm trying to redact it because of confidentiality clauses, but I'll give you a sample I can share eventually. It's basically a definition of how we do testing, who does testing, the sort of roles that we engage in testing, the sort of testing we do, the sort of tools we use, how we use it, who, what, everything, everything. You define performance, functional system, you define what a project manager would do, what a test manager would do, what a tester would do, how long it will take you, who is responsible for X, Y, Z, the resources you need, the tools you need, the sort of tools you have, Jira, Selenium, WebDriver, and all of that, application testing suite, test project, test rules, all sorts of things. That's what you put in your strategy. It's high level, it's usually well documented as well, because this test plan will become an extract of the strategy, because at any point in time on your testing project, you are only doing a certain part of it. You're not doing functional system integration, everything all at once. No, you probably are doing UAT. You're probably doing just system testing. You're probably just doing one of it. But the strategy will have told you, this is how we do it. This is who does what. This is the tool we use. This is the definition of our defects, priority and severity, and all of those things. Okay? So you need to remember that these are things that you get questions about a lot in the interview, in exams, and everywhere. These are like the building blocks of the understanding the concept of testing. So you need to understand how these things work together, who does what, and how they use it. So the strategy provides a general description of the test process. Okay, usually at the organization level. Some people will say at the product level. I don't want to believe you should have a test strategy for a product, especially if we are a software house and we're churning out product after product. I don't want to have several test strategy, because I'm doing Coca-Cola and then doing Fanta and then doing Sprite and then doing Pepsi. So I'll have a test strategy. No. What I would have is I would have a Nigerian bottling company kind of test strategy. Those are the guys that do Coca-Cola, right? So I'll have a test strategy for NBC, and then I'll have a test plan for Coca-Cola, have a test plan for Fanta, have a test plan for Sprite, one for Pepsi, one for Mirinda, one for whatever. But the test strategy sits at the top. Does that make sense? So the test strategy usually includes strategies like analytical strategies. Is based on requirement or risk. Like risk-based testing is an example of analytical strategies, and requirement-based testing as well. A few of those. It could be a model-based. You could have business process model on which you can base your test strategy, something like reliability of products, something like consistent availability of products, things like that. It could be methodical. It could be based on a certain methodology or a taxonomy or common or likely type of failures, or a lot of different things. Mostly when you're testing web projects like web pages, or web applications. Those are the kind of things you look at. Like what sort of failures? What's the pattern of failure? You look at the method and then you define your strategy against that. So you make sure that everything is covered. Process compliant, direct strategy, regression averse, reactive, all sort of different strategy types. Read it in the notes, get an understanding of it. But at this point in time, what you need to know is a test strategy is a document that defines how an organization does testing. A test plan is another document that sits below test strategy, which defines how a project is done. What you do in a testing project, that's what a test plan does for you. Okay, don't forget we're talking about planning, test planning. All of these things are done in planning. Okay, but it's important for you to understand, because when your manager or your test lead or whoever is doing all these things, you won't be left by yourself twiddling your thumbs thinking, oh, it's not my turn yet. When it's my turn, I'll do something. No, this is the thing. While your manager or whoever is doing this planning, setting up this document, you, on the other hand, you will be reading these documents to understand how these things impact on you. What exactly do I expect you to do? Do you get what I'm saying? What exactly is my input into this thing? What do I need to do? In the plan, if I say, for this system testing, we're going to produce 400 test scripts based on this requirement, that's your cue to go. That's your cue to go. You know what? I'm on it. I need to start churning out the test script. If you don't know, if you don't have any pre-knowledge of it, if you don't have any documentation, you know what to do. You start exploring the application itself, go into exploratory testing mode, sit down and start looking at the concept of it, start looking at it, and get an understanding of it so you can start producing your script. Okay. So all of this goes in tandem with one another, because your manager is not going to do the planning while you're twiddling your thumb waiting. And then when it's done, he passes it to you, and then he sit down as well, waiting for you to finish. No, if you approach it that way, you would never finish the project. And those are the things that a test strategy will define. This is how it works. Okay. So this is why it's important for you to understand it. This is why it's important you know how they work together. This is why it's important for you as a tester to understand the language your test lead or test manager or whoever is saying or is passing to you, so you can all work together. Because most of the time you have very limited time, and because test planning period is a period with very, very little output. When you're planning, I call it the stressful time. When you're planning, no one sees any output. You're just sat there at your desk, sometimes writing, sometimes looking at your screen. A lot of people would not know that you're doing anything. A lot of people will generally just assume that, oh, the testers, they just sat there not doing anything, they're just wasting our money and wasting our time, blah, blah, blah. That's not true. What we're doing at that time is we're racking our brain, thinking, how do we resolve this? How do we test this? What sort of planning do I need to do? How many scripts do I need to write? What's the quality of the script? Because when you write the script, someone has to read it and review it, and all of those things. What tools are we using? How do we define this? X, Y, Z? Because it's not an output centric activity. A lot of people misunderstood those times to be the testers are just sat there not doing anything. That is why every member of the testing should be on the same page. Otherwise, there will be confusion. You might think you're not being carried along. You might think this is not happening. You might think, you know what, I don't understand what is happening here. I'm being disillusioned and I'm getting out of here. I've been in a team before that a guy just didn't come back to the office. He said he's had enough. He just left. And when I called him and asked him what the problem was, he was like, Ade, just not getting it. And I'm very, very disillusioned with the office. I'm not coming back. And that was it. He did it. So you need to understand, and that's why I'm telling you all this is because this is very important for you. Now, part of the stuff that is defined in your strategy document is the entry and exit criteria. Now, you can define it in the strategy document at eye level. Otherwise, you can define it in granular details in, excuse me, in your test plan. Now, what are these things? Entry criteria, exit criteria. For example, we want to test something. Now, you can't just get in there, sit down, start testing. What if it's not ready? How do you know it's ready to test? Now, entry criteria is a set of conditions that must be met before you start testing. Now, I use the phrase before you start testing. Testing does not start at execution. Step one, click on expected result is passed. That's not where testing starts from. Remember what I've been talking about in the last half hour. Testing has actually started because of the planning. We are planning, so that started testing. Now, I say entry criteria is a set of conditions that must be met before test execution starts. Now, there are different phases to testing, the planning, execution, reporting, and all that. Now, before you start executing the test, these conditions must be met. For example, the application should be ready. The environment, if you want to call it domain, the domain should be stable, should be ready, should be available 24/7. The resources should be there. All of those things must be met. I listed a few entry criteria is not testable requirements. You need to know what the requirements are. You need to know the use cases, the user stories, the approach you're using, the kind of model you're following, availability of test items and test environment, any tools if you're going to use to test data, where do you get test data from, and stuff like that. Those things must be ready, must be provided before we can start executing our test. Okay. Now, exit criteria is the opposite of it. Exit criteria basically means before we can say to anyone that we have completed testing, we, as the test team, as the testers, must have met the following conditions. I'll say that again. Before you can say to anybody, oh, we've completed testing on this project, we should have met a certain set of conditions. Basically, if we have 100 tests, we should have run all the 100 tests. If we're going by the part coverage, we will have covered all the defined coverage. If we're going by the number of defects, we could define, we don't want to have any showstoppers. We don't want to have more than 3 P3s. We don't want to have more than 5 P4s. We don't want to have more than stuff like that. They will be defined well ahead. Testing is a kind of a journey where you define the destination before you set out. Before we leave where we are, we know where we're going. So we've already defined it. So there's no scope creep allowed. There's no one shifting the goalpost. There's no one saying, oh, but you haven't done this. But no. Everything has been defined, planned before we got to this one. Okay. Now, this entry and exit criteria is a big thing. It's huge. I would say pay attention to it. Practice this. Take something that you want to test on your own. Look at something and say, I'm going to test that, but what do I need to test that? Write it up. Let me see what you come up with. Okay? Okay? And it says here definition of done and what's not done, or definition of ready and done. When you say something is ready, what does it mean? It means that you're good to go. We can start now. You can commence. You can go now. Let's go. It's ready. When you say something is done, that means we are back. So entry and exit criteria basically means that we are ready to go. We're back. We're done. It's all done. Okay. You need to get the concept of that because it's really important for you to understand it. Okay. Now, when all of that's been planned and you've set all of that out, you come to a test execution. Okay. Now, test execution basically means how do we run the test? Who does what? How many scripts can we execute in a day? How many people do we have? On my last project, I look at the number of my team, I look at the number of scripts I've got to run in a day, and I go, right, guys, you guys are going to run 72 scripts each. Sometimes we have just 72 scripts to run. Sometimes we have to run over 1,400 scripts in a week. So we have to create a schedule. I'll show you an example of the schedule here as well tonight. We have to have a schedule on which we plan. So we use that for execution. Now, test estimation, whichever technique you use, there's no right or wrong one. And most of them are not usually precise. Really, they are not precise. They are usually close. Like I can guess how long it will take me to do something. Or my guess can be said to be accurate if I'm like 1 to 3 days out. But if I'm like 2 to 3 weeks out, I'm off the chart. It's not right. Okay. So I need to remember that it's just what it is. It's an estimate. I call it guesstimate. I'm only guessing. I'm only saying that, look, I should be able to do this in 2 weeks with 5 people. At the end of the day, I might get 5 people and end up doing it in a week. That's fine. I might get 5 people and do it in a week and a half or 2 weeks and a half or something. You can't really tell what's going to happen. That's why we call it estimate. And the two technique we used is based on metrics. So basically, you are looking at similar project that you've done before based on similar typical values or the number of people you have, the number of scripts you've got to run, the number of things you've got to do. You can do your estimate from there. Or you can use expert-based technique where you can, based on experience, the things you've done before, you can decide to go that way. But whichever way it goes is usually very close. And how close to being real or how close to being accurate depends on the person doing the estimate, how long they've been doing it. But in your estimation, you need to know what's important. You need to know what you're looking for. You need to know the resources you need. You need to know the scope of what you're going to do. You need to know the tools you've got. So those things will enable you to properly make an estimate of, okay, you know what? I'll probably be able to do this in 2 weeks. Okay, don't forget that. That is really important. Okay, now let's talk about factors influencing test effort. So what are the things we see when we're testing? What are the sort of things that happens? We talk about product. Now, some products have risk, very high value risk. But we look at the quality of the test basis, test definition, the size of it, the complexity of it, the domain, the simplicity or complexity of the domain, the structure of it, how it does work, the product itself, what sort of things it does. Some are critical, finance, human, clinical, and all of that. We look at complexity or the simplicity of it, the nature of the product itself. That would influence how we test. I believe I've told you before that, for example, in my sector where I work, we test to ensure that our system does not contribute to patient death. We need to make sure whatever happens, this system does not contribute to killing someone. Okay. In the financial sector, for example, they need to ensure that they are not hemorrhaging money. They're not just leaking money. Imagine you going to the ATM tomorrow and the ATM is just spilling out banknotes. What do you think has happened? The software has failed. Now, if the software failed, what do you think will happen? People will just run there and gather money and everybody will disappear. How many people are you going to chase? That system will have failed the bank. Those kind of things are the product characteristics because that would affect how the product is tested. Then we look at the development, how it's developed, what language has been used to develop it, on what platform. Some we have Windows and Linux, Unix-based product. You have some cloud-based. You have some desktop-based. You have some all sorts of things. All sorts of how was it developed? What's the mode of development? That will affect how we test it as well. But predominantly going forward, everything is tending towards cloud. But that doesn't take away the fact that we still have desktop-based applications. We still have all sorts of different applications everywhere and stuff like that. Then we talk about people characteristics. For example, you might have a team of 6 and their efficiency level might be out of this world. Okay, they might be so efficient that you run through everything like in no time. You might have a team of 20 and their efficiency might be 0. You need to look at the skill set you've got, you need to look at the domain knowledge, you need to look at the product knowledge, you need to look at all sorts of things. How well do they work together? What's the leadership followership relationship is like? All sorts of those things. Okay. Some people are emotional. So they come to work, they are struggling with something at home or back out of work, and they break down in the office, and you'll be wondering how to, those kind of things affect your work, really, because you need to look after your team, basically. And then test results, like I said at the start, your test result is just what it is. It is not right or wrong. The definition about whether it's right or wrong is not entirely up to you. You won't do that. Okay. So remember those things as you go forward. So monitoring and control. Now, this is another part of test management that a test manager does. But the input into providing this report will come from you, because if you look at the graphic here, I've talked about the planning, I've talked about the design, I've talked about the execution. Now I'm talking about control, reporting, and all of that, and monitoring. Now look at this. When I, as a test manager, have drafted the plan, I've reviewed the plan, I've given you the plan, you've seen it, and you've seen what I'm trying to do, we see what I'm trying to achieve and all of that, fine. And then you've started your execution, you've collated your result. Now, when I'm doing my report, where do you think the report comes from? It comes from what you're doing. So if I have to report, I'll show you a sample of it now. If I have to report that we've done everything, it means you have done everything I've asked you to do. Okay, so I will pay attention to this as well. This is really important. You need to know how these things fit from one to another, from the planning to the design, to the execution, to control, monitoring, reporting, who does what, where you fit in to this flow, what is expected of you, okay? And when a test report is being written, like I said, the content of it usually comes from the activity you, the tester, is doing. So I wouldn't just sit down in the corner and start drafting things off my head, saying, yeah, I can do this way and do it that way. No. Okay. So you need to pay attention to those. Now, this one here, it doesn't really come up verbally, physically, all the time. But you will come across this a lot as well. Configuration management. And the reason being, most of the products nowadays, well, from time immemorial, they are modular. They are built in modules. Now, you might have to change settings or configuration is called. Now, this affects how you test. Okay, you need to be able to maintain the integrity of the component or the system you are testing at all times, relative to any changes being made or where it is in the project lifecycle. So if we're testing version 3, for example, and they are tweaking it to make a version 4, someone should be able to version control all the test scripts that worked for version 3, because if we have to roll back, our regression test exercise will be running of those scripts that work on version 3. Does that make sense? If you listen to it a few times, you get it. So I have a piece of software here, which is version 3. We've tested it, all of us, and it works, and we're happy with it. And then the vendor came back and said, we've made some upgrade. We've changed XYZ. In the past week, Office 365 changed to Microsoft 365. I don't know how many of you noticed it. Now, after the change, immediately, some of the applications failed to work. Why? They were working before. Nothing's really changed on it. I haven't, they were working yesterday, but they've changed something in the configuration, not necessarily the actual product, maybe in the environment, the setup, how it's, a lot of different things. This is why this is important for you to understand, because before you can test the change, you need to understand what the change is. And if the change fails, You need to be prepared for a rollback. How do you prepare for a rollback? You version control everything that worked yesterday. So when we come in today and they say, oh, we've changed everything. Well, fair enough. All of the version 3 script would work on version 3 of the application. So let's move to version 4 and we start testing it. If it fails, we have a version that works that we can roll back to. If it works, oh, we version it again until the next change and the next change. That's why you see some, if you go into your browser, if you go into any browser you're using and click on About, for example, Internet Explorer or Microsoft Edge or Chrome or anything, you see the version number. That means they've been making changes and making changes and making changes. Every time they make a change, they give you a different version number. If you go to Java, for example, there's Java 16 point something, 13 point something, 7 point something. And that means they've been rolling this product over and over and over and over and over. That is why we, as testers, need to understand configuration, because you need to understand the change between what you have and what they are giving you or what they are bringing. I hope that makes sense. But if you read it a few times and you have any questions, let me know and I'll answer your question. Okay? Now, let's talk about risk. What is your definition of a risk? What do you perceive as risk? So there's so many definitions for it, and I don't want to waste your time because we could sit down here and define risk as a lot of different things. But risk involves the possibility of something happening. It's not happened yet. Don't confuse risk with issue. No. Risk means it might happen. And if it does happen, it will have an adverse effect. That's a risk. For example, if I give you 10 pounds, there's a possibility that you may not give me the 10 pounds back, or you may not be able to give me back, which means I will have lost 10 pounds. Another example, I'm old. I want to go and play football. If I go and play football with teenagers, there's a possibility that they'll break my leg. And because I'm old, the doctors might not be able to fix my leg like they will fix the leg of a teenager. That's a risk. It hasn't happened yet. Do you get what I'm saying? So, this is my eyes. Jeez. That's better. Yeah. Sorry, it's dark, but the sun is in my eyes. So, that's the risk. Okay. Now, on a project, we've classified risk into two different groups. There are product risk, that's risk associated to the product itself. And there's project risk, that's risk associated to the project as a whole. Now, product risk, for example, are things that affect the software if we are dealing with the software. For example, the software might not work, it might not do what we said it's going to do. We might say that, oh, this software will give you loan at 5% interest rate, and if it doesn't, it's failed. We might promise a lot of different things. We might say, this will work like this, or this will work like that, and stuff like this, but it might not work. It might do what we said it would do, but it might do it wrongly. It might do it in a different way. The computation may be wrong. A certain code may not work. Response time when you are trying to load an application might be too long and stuff like that. Those are all product risk. It doesn't mean it has happened yet. As long as it has not happened, it's a risk. Okay, those are product risk. All right. Now, what are project risk? Now, project risk is multidimensional because there are so many people involved in a project. When you gather people together, there will be differing opinions, there will be difference of attitude, all sorts of things. There's going to be people that don't get along. There's going to be people who get along. There's going to be people who don't want to see each other. There's going to be people who dislike each other. And all of these people are supposed to be working together. And if you're not working together because you don't like each other, you're working against each other, which is against the objective of your project. It's as simple as that. So we have Project risk is project issues. For example, we may have delay in delivery. I know that quite well. A few people here knows that quite well. We may have the environment is not ready. We don't have a project manager yet. We don't have estimate. We don't have funds. We don't know. Oh, there's been sudden change at the last minute. So the delivery is going to be delayed. That section of the project team is not available. We don't have budget. We don't have the business analyst. There's no requirement document. Those are project risks for project issues. Organization. We don't have staff that have the skill set. I work as a contractor. Most of my clients engage me because they don't have staff that have my skill set. And that's why they pay me so much. That's why they pay us testers so much. Testing is not something that is traditional to a lot of organizations, but every organization tests in one way or another. Everybody do testing, or everybody is supposed to do testing, but they don't. So most of the time when I turn up at somewhere, I go, oh, I need testers. Oh, you can take 3 or 4 of our people. Are they testers? No. Have they done any testing? Of course, no. Did they have any testing? No. How am I supposed to test it? This is what I'm saying. So there are organization issues, there are political issues. You know, people might not want to communicate with you because they don't like you. People might not want to talk to you because they think, oh, he's come here, he's going to get paid loads of money, and he's going to take my job, and I'll be redundant, and all of that, and all that. You know, politics in the office. A lot of people in the office setting will tell you, oh, there's politics. See that guy doesn't talk to that guy. See that guy and that guy, they are best of friends. And if that best of friends have information that can move the project forward, and they don't tell you because they don't like you, what's that doing to the project exactly? That's taking the project backwards. Okay, and then technical issues, supplier issues, all sorts of different issues. Okay, so those are the things that could delay project. Now, I've given you on the graphics here an example of a risk-based testing. What the risk is, what the testing objective is, what the technique is. So we've identified risk. How many of you have heard of a document called RAID log? RAD. Let me type it out for you. RAID log. How many of you have heard of this before? Or do you know what a RAID log means? RAID log means risk, assumption, incidents, dependencies. Go and Google it and read about it. So basically, risk is something that's not happened yet. Assumption, we making assumption that this might be this might happen, this might happen. Dependencies means for us to move forward, we need X, Y, Z. You know, so most of those things you need to be mindful of as well. Okay. Now let's talk about this. Last week I gave you a task. I said, go and test this website, document what you found. Okay. Now 2 people got back to me. They sent me their work, what they did. Okay. And I'll come back to that in a bit. Now, the whole reason I gave you that assignment before this class is to show you how to report whatever you do in a situation like this. So we've come to a point of talking about defect management. Now, defect we defined at the very first class is different from everything you think you know, but it's a defect for a reason. It means it's not working. Now, this is something as a tester you would do forever. As long as you're testing, as long as you're practicing testing, you would always come into defect management. Even though it's not the sole focus of testing. Testing is not just Francis, you're just responding. Thanks for that. I know. That's the whole point of it. Right. So sometimes the focus of testing is not to find what's not working. Sometimes it's just even to understand what the application does. For example, when you're doing exploratory testing, you're not basically looking for what's broken. You're just looking for or trying to understand how it works. But as long as you're practicing testing in one shape or form, you'll come in contact with this defect management. This is huge. This is like about 60% of what testing is about, according to the perception of a lot of people. But as you do it, as you get more knowledge and experience and understanding of it, you will realize that it's not that big, even though it's very vital to it, because you'll come across things that don't work. You have to report it. You have to report it in a way that people would understand, in a way that it doesn't waste everybody's time, in a way that once I receive the report, it tells me everything I need to know. Okay, so I want to show you a few things now, and these are the things that I've prepared to show you. So I'll go out of the I'll go out of this, and I would show you. Where is it? Uh, Bear with me one sec. So I want to show you this document. I want to show you this document. Yeah, this one here. So, okay. So if I go back here and say share, that one, share. All right. Can you guys see my screen? So basically, this is a defect report template. Now, in the presentation as well, I've listed things that you need to put in your defect report. Now, you need to state the time, the date and time. When did it happen? The reason this is really important is you might be testing an old version. By the time you were doing that, we might have changed the version. So you need to tell me when it happened, what date, what time did it happen. Okay. You need to tell me the environment. Um, the environment basically means what container were you testing in? For example, if you are testing a web application, are you testing it on your phone? Are you testing it on a tablet? Are you testing it on an iPad? Are you testing it on a laptop, on a desktop, on a Kindle? Whatever. You need to state the device. You need to state what browser you're using. For example, if you're web testing something, you need to state if it's Safari or Chrome or whatever. You need to state the environment. Where did you do the test? You need to tell me um, if it's user-based testing you're doing. For example, the website I asked you to go and test last week, you can only be the user. If I give you an admin login, you become an admin. You need to state that if you are reporting a problem to me. Oh, this is the user I will have used. I went in as an admin. I went in as a manager. I logged in as an end user. You need to state that, and then give it. You state your test data that you use for your test, so I can identify it. Say, well, it didn't work for me. My email address is wbush@whitehouse.com, or and this. And you need to state that. So when I look at it, I can see, or if I have access to the log, I can see what you've done, so I can troubleshoot it and fix it. Or the developers should be, not me. The developers should be. And then you put a very sensible subject in. Don't just say issue one. Don't say defect number one. Don't say defect number three. No. Say something like the blog link doesn't work. The resources page doesn't load. The contact us form failed. Things like that. Then go ahead and describe what the issue is. Just tell me when I go on the blog page, I clicked on the blog and nothing happens. Next time I clicked on the blog, it comes back with JavaScript error and all of that. And then tell me what you were expecting. Oh, when I click on the blog, I expect the blog to load. I expect the resources to be displayed. I expect the list to be displayed. I expect this to happen. That's what you expect. Now, tell me how you got there. What did you do? If I want to try the same thing you've done, how did you do it? Tell me exactly in bullet points how you did it. Number one, I clicked on the home link. Number two, I clicked on the contact us form. Number three, I input data into the contact us form. Number four, I clicked submit. And then at the bottom of that, you put a screenshot on it. You put a what? A screenshot on it. Now, that's how you do a defect report. Okay. So last week, when I said to you, I need you to go and do, I need you to go and do that on the website, I expect you to come back and say to me, yes, I did it. Like Francis just literally gave me a breakdown of what he did, which is fair enough. That is true. You haven't learned about this now, but now you know. Okay, so this is how you make a report. Now, the very last slide I'm going to show you is this one. Now, look at the graphic there. A good bug, well, bug, defect, whatever you want to call it, a good bug report can save time by avoiding miscommunication or the need to ask for additional communication. So if we're on time pressured project line and you find a problem and you are reporting it, all of these things listed here should be included in your report. This is really important because you will start practicing this from as soon as next week. So if you're testing something and you come across a defect, you need to structure it in such a way that it makes sense. I can follow it without the need to email you to ask you for further information. That will waste time. I don't want to have to call you to ask you what the problem was. I don't want to have to call you to say, what exactly do you mean by this? You have to make it so simple, straightforward to read, so I would understand. And then you put the screenshot to it at the bottom of it. Now, if you look at that thing I shared with you, if you look at the thing I shared with you earlier, where I said, this one, I'll show you this one. Now, if you look at this document I've shared with you now, I've made some example description here. Now, when you have a P1, so this would help you to tell me what priority you think it is. Now, you won't always get this from everyone, but this is a class. So I'm teaching you. So I've left some form of description here. Let's go through it. The first one, P1, house is on fire. We are all trapped inside the building with no access to any exit point. What's going to happen? We are all going to die. End of story. We can't get to exit point. We can't get outside. We can't make phone call. We can't do anything. The house is entirely on fire and we are all trapped. That's a showstopper. Nobody's going anywhere. It's done. Okay. Next one, house is on fire. Major exit point blocked, but we are able to access other emergency exit. The situation is as bad, but we can get out. We can get to emergency exit. Okay, whether we can get out or not, but we can get to emergency exit. The next one, house is on fire. It looks like a big fire, but we have fire extinguishers that can contain the fire. So we still have the fire incident. It looks like it's big, but all of us quickly we have access to extinguishers and we can fight it. Okay, that's another one. P4, we saw a huge smoke. We think there's a fire, but we're unable to see any fire. All access to exit the building currently opens and not blocked. Fire extinguishers all at the ready, which means we think there's a problem, but there might not be a problem. So we're safe. We're not in any danger. And the last one, we think we smell smoke. We could not find any smoke. We could not find any fire, but we're still looking open to nip any fire in the bud. Those are five different stages of priorities that I've defined. So those are five things that I'm showing you to say this is how we define application. This is how we do it. So of those things, you need to be mindful of it. You need to remember that this is how this thing works. So when, for example, you're participating in a project and we say to you, okay, we need you to test X, Y, Z. Any issue you found, you need to report to us. If your report is accepted, you get paid for it. So the amount of money you make out of the project depends on how many of your report is accepted. Not that the bug you found is not valid, but did you put the report together in such a way that we could understand it before someone else does? Did you put the report across like, okay, we understand perfectly what went wrong there, and we will deal with this. Thank you very much. Or we have to keep chasing you, we have to phone you up, you have to email you. By the time we get you to tell us what's happened, we've spent more than we could have given you if you have given us all the information at once. Do you see the point? So it saves time to put your report together to make sure your report has everything in it, to make sure that nothing is left out of your report. If you think it doesn't matter, don't worry about it. You will not be in a position to tell what matters and what doesn't matter. But what we are saying is we need to let everyone know that this is the problem I found. This is everything you need to know about it. And then stick a screenshot there. Now, your screenshot should be the entire screen, capturing the date and time of your screenshot at the bottom of your screen, of your monitor. You know, there's date and time at the right hand bottom of the screen, of most screen. On devices is on the top, on phones is at the top. So when you're capturing the screenshot, it's easy to do on your phone. You just take a picture. Just take a picture of your screen. That's it. On laptop, you take a screenshot of it. On iPad, you take a screenshot of it. It's so easy these days to take a screenshot. So all of these things that you've learned today are really, really important. As a tester, you need to be mindful of it. Okay, so let me quickly show you a few documents that I've prepared for you so you can see what I mean when I say this is what this looks like. The first one I'm going to show you is a test activity tracker. I'll show you what that means. Is this one shared? Now, if you can see my screen on here, this is when the test was being prepared. Now, this here are the individual activity that we have to do while preparing for the test. Now, this is the level of sign-off that I need at that point. As at the time I took a copy of this document, these were the different status, as you can see. And then these are the people that needs to sign them off. Now, where you see PM means project manager, it could be program manager. TM means test manager, business analyst, TM, BA, PM, and all of that. And then similar thing for execution. You have, this is what we're doing for execution, and this is the plan in Gantt chart. Okay, so that's one document. Okay, so let me show you another one here, and this one is quite, it's a little bit, this one is a bit big, but in this one, I can show you, a lot of things that I've talked about today. I can show you a lot of things I've talked about today. So for example, here, now, this is a test schedule document that I used recently. Now, if you look here, you'll see a lot of different figures, statistics. Now, this is when we actually did execution of the test. This is how many tests we run in each day. And all of this is done by formulas. As you can see, they are not just figures, they're all formulas which someone has to write. And then I have all sorts of graphs here. Let me see if I can reduce this further so you can see the whole screen. I have all sorts of graphs there. And then I have the dashboard here. The dashboard is a myriad of different formulas, but this is taking stats from everything that we're doing. And then I have the exit criteria defined. As you can see, it's all green. And then I have different stats, P1 and P5 and all of that till date. You have the blockers there. Then you have the graph there and all sorts of graphs and all sorts of different graphs and all of that. And then in here is the actual data. This is the actual data that gave me that report I've just shown you. Now, if you look in here, you see the test scenarios, each days that we run it, the reference and the title and all sorts. the schedule, the date, the results. Now, this spreadsheet, I designed it. That's what I use to collate my test output. Now, it's from there, and this is the bulk of my test planning activity, that I get my defect report here. Now, this was extracted from a tool called Method M. When we get to talking about tools, I'll talk you through a lot of them, but don't worry about that. But this is the raw data from my test defect that we've raised. As you can see here, it's priority, different P1s, P2, P3. There's loads of them. As you can see, there's so many of them, like 1,000 plus, But this is the test estimate I was talking about. Now, when you look at this, you look at number of plant tests, 1,680, and I have 5 people, and we have 12 days, which means every day we have to run 140 scripts. Yeah, which means every day each of my testers has to run 28 scripts. Which means every day, currently, ideal working days, we should run 28 scripts as a team, 16 scripts per person. Yeah. Now, this is an estimate. We ended up not having 12 days. I can't remember how many days we had here. I think on some of them we had 5 days. On some of them we had 7 days. On some of them we have just a week. But we still have to deliver. We have to produce those things so they would know that this is what we're doing. So I'll produce this. I'll produce this to you. So all of these samples, I need to take out some data out of it. But I'll produce this to you as resources on the website when it's finally ready to go, and you have access to it. Okay. This is to enable you to see what I've talked about, because what we've talked about today, you will come across it every single day of your testing career life, because that's all you do. You get document that you have to analyze and review. Someone somewhere has done a plan. There's a strategy somewhere. I was going to show you a few more documents. I don't know how much time I've got, but there's no stress about that. I've got a sample test report here that I can show you. Now, if I show you this report, uh, this one was approved. Okay, that one was approved, and then uh, I took a copy of it, but I can't share it as it is because it's quite recent as well. But if you can see my screen, you see how recent it is. Normally, you have a test report here. If I show you this, show me the navigation, you see this is the content of the report. So basically, as you can see, the watermark is approved. Someone has to sign that bit. I've taken out some details out of it. I still need to take out more before I can publicly share this. Now, this is everything we tested. Okay, this is everything that was tested on that program. All of this thing here that you can see here, that's everything that we tested, and this is the plan that we followed. And we had 5 days per cycle or 10 days or whatever days per cycle. Now we have scripts that we have to write. We have test cases that we have to execute. We have the test coverage that we've done. We have some other testing that we did, maintenance training, exit criteria, as you can see. Is well defined here, 0 P1 and 2, 30 P3s, 40 P4s, and all of that. And when we're doing the report, I have to report that we meet the exit criteria. As you can see, we must have 0 of these, 30 and 40. We missed that just by 1, but we meet it anyway. So that's what a report looks like. Now, you must have seen some of these graphs from that spreadsheet I showed you, because that's where the data came from. So you can begin to see how all of these things work together, because they do work together, because you have to use all of these things in tandem together to do your testing. And that's how it works. Okay. So at the end of this class, what I need you to have learned, what I need you to have learned is this, and I'll explain to you why I'm saying this to you in a minute. So at the end of this class, I need you to have learned that test organization, you should be able to explain the benefit and drawbacks of independent testing with degree of freedom. You should be able to identify the task of a test manager or a tester or a test analyst or any tester that they tell you to identify. Should be able to summarize the purpose and content of a plan, know what the test plan is, know the difference between test strategy and the plan, the different test strategies there. The objective is well stated in my note as well. So you need to be mindful of those things. I'll provide my note for you to read as well. So the reason I'm telling you all of this is for two reasons. What I'm rounding up. One, um, the two people that sent me their coursework last week, if they choose to go ahead and get certified, their foundation certification examination fee will be paid for. They don't have to pay for it. It will be paid for. Both of them, they know each other. I'll contact them and we'll arrange it after we've done all of our classes. For their foundation examination certification course will be paid for. They don't have to pay for it. Secondly, very soon, next couple of days, you will get an email from me. So I'm seeking your permission to email you that I want you to participate in a live project. Now, everything you've learned so far will come in handy. So you need to start brushing up. But you're coming to a point where you'll be getting projects to actually practice with. And these are not any project. These are live projects. These are products that have been developed that are coming into the market that we will be testing. So you will get an email. If you get an email from me, please be aware that the platform is members only. So I expect you to register. I'm trying to build a community of testers. So, and that's what we're going to do. So everybody that get invitation to participate will need to register on that platform, okay, before you can participate. The details of the project, what we expect of you, a few other resources will be there. All of the courses that we've done so far, with the link to the videos, all of the notes, the presentations that will be there as resources for you. So you can reuse them, you can use them again as much as you want. But the project will run for a certain number of days. So you'll get an email from me to get involved in the project. It's not compulsory. If you don't have time or if you don't want to do it, I would understand. It's going to cost you 100 naira because you're going to register on the product that you're testing. But whatever you spend will be refunded to you. There will be information about how much you get paid for it, for participating or for producing the defect or whatever it is. All of that information is being collated at the moment. But I'm hoping by Tuesday or Wednesday, I'll be in a position to email you. So please, if you don't have my email address, please let me know or contact Pfizer, or you need to ensure that you mark my email as safe so that you get the email directly as soon as I send it. And this will be in between now and our next class. This will be ongoing for a few days, so it might be over a week. I don't know how long it's going to do yet, but so that's why I was saying to you that you need to understand distance, because what you've learned today, you'll find out that it becomes handy. Now there will be a defect template for you to use. You're free to design your own if you want to, but the report has to be in a format that is easy to understand. Okay. Also, we have a catalog of defects already. I'm still thinking whether I want to share those with you or not. Because if you report a defect and we tell you we already know about it, I don't want it to sound like we're just saying that because we don't want to pay you. So that's a decision for me to make. But we'll do it in such a way that everybody who participates will learn a thing or two, and we'll all get several benefits out of it. Okay, so that's what I've got for you today. Any questions? Let's have questions briefly without wasting time. Do you have any question? Because I'm attending a conference online and it finishes at 8:30 today. So I still want to catch the last hour of that conference. So if you have a question, talk to me. The resources, yeah, come, Jalili. The resources from this class will be sent to you tomorrow. Um, if you didn't receive any for last week, please let me know. Because I think I sent you out, but I'll try to send you out again in case you didn't get it. But I'll send the resources out after this class, probably tomorrow, because I'm in a conference till 8:30 tonight. Um, When you finish class, please remember to leave feedback for me. Your feedback is really important. If there's anything that you want me to change in the delivery, or if you want me to improve on something, please feel free to say. I'm trying to give you knowledge, but it will help me if you help me to give you the knowledge in a way that you find quite understandable, that you find easy to assimilate. I don't want to assume that everything I'm doing is right or wrong. Francis said, apart from raid log, is there any other log? There are so many different logs. There is risk log, there is raid log. It depends on what the organization calls it, okay? But don't worry too much about what it is called. As long as you understand the concept of it, what it does, what it's meant to do, and who is using it to do what. That's what you need to be mindful of. I wouldn't bother myself with the fact that I won't bother myself with the fact that, oh, is it called something else? Just understand what it does. If they can call it jumbo log or whatever log, as long as you know, if I get a risk or if I'm raising a risk, this is where it goes. What they call it doesn't matter. Chalili said, I did the registration on this website on a course. I was able to register a course, same course twice. That is wrong. Now, if you register for that course and you paid, that means they've taken your money twice for the same course. That is not right under any circumstances. That is, the software has failed. Now, that might be because something's broken. That might be because no one tested it. That might be because of so many things. But that should not be happening. It's like saying you bought a recharge card and then your bank charged you twice, well, which is quite possible in Nigeria, let's be honest, but that should not be happening. So now, even if it's a free course, it's not free. The reason it's not free is because at that point in time, you are investing your time. The course tutor is investing his time. So everybody is investing something. So it's not actually free. So, like for example, the weekly classes that we do, it takes me like 2 days to prepare for it. Um, if I want to charge you for the 2 days, that's like £1,600. So nothing is free because you have to find time to attend. I have to find time to prepare to deliver the course. All of us have to be here. You are spending money on data. We are all spending money on this. So nothing is actually free. Now it's free because you are not paying money, but they have your data. They'll be sending you personalized advertisement. There are so many things they're getting from you that you physically are not seeing, but it is not free. And that's because everybody is paying in one way or another, but that should not be happening. Okay. So does anyone else have any question? If there's no question, thank you so much for attending. Please leave a feedback. If you have any comment or review comment or anything, please send them over to me. I'll see you next time. Enjoy your weekend. Please be safe. Be safe. That's really important. If you don't have to go out, please don't go out. And I'll see you at the next class, maybe next Friday. I wish you a great weekend, and I'll talk to you guys later. Thanks so much for coming.